Thank you, everybody, for your wonderful presentations. A really interesting session. Two issues have been alluded to throughout, but not directly addressed. One is tabletop sweeteners. So most people that drink tea and coffee use some sort of a sweetener, whether it's sugar or an intense sweetener, bulked out often with a polyol. Are they captured in any of these observational studies? They're not in the Australian Blue Mountains Eye study, which I was part of. And the second one is the pharmaceutical, and that includes dental care, where a lot of intense sweeteners, of course, are used. I don't think they're captured in these observational studies, either in supplements as well as medicines as well. So we've got two major potential sources of intense sweeteners that I don't think are captured in the observational data. I'd be interested in your thoughts about that.
We do have added use of artificial sweeteners, some specific types. In general, we don't know whether they were added, exactly where they were added, but they, whether it was beverages or some other use. So, but in addition to the sugar-sweetened beverages, or artificially sweetened beverages. So we have, and this is also problematic that those have changed over time so much. I think it's going to be very difficult to do good epidemiologic studies of those that are added to other foods other than beverages.
Could it in part...
So I was going to say, we just looked at beverages, but if you have 24-hour recalls, so I think NHANES, NutriHealth Santé, probably UK Biobank may have some capture of tabletop.
Could it explain in part some of the disconnect between the randomised controlled trial data versus the observational data?
I don't think there's really a disconnection at this point. And part of the issue is that the overwhelming amounts are from the beverages, or at least until very recently. It's still small, equivalent to like a teaspoon or a couple teaspoons of sugar. But like, given that there's like 16 teaspoons in sugar, then sweetener equivalent in the artificially sweetened beverages, the amounts are huge. And I don't know if somebody has a statistic at hand, but well, I think someone did show it. I can't remember if it was you, John, that at least of aspartame and several others, the beverages account for over 90% of the use. So I think that's just a little bit of noise. It's probably not going to be much of a problem.
I think there's something interesting too with, I think in Europe, the tea and the coffee is a lot more than maybe in Northern America, where we just consume soda, right? So there might be something there that we should look at, but at least in North America and in my trial as well, we didn't have much of the tabletop sweeteners.
Just to add to that, I think NutriHealth Santé actually, they claim that they have been able to capture all the intake using 24-hour recalls, and then they have separated tabletop versus beverage. They've shown relationship of I think harm with low-calorie sweeteners. How much are they able to account for reverse causality, residual confounding, and other issues? That needs to be seen. I'm not totally convinced with their data.
Could I just add to that? There is something strange about that study that I don't understand, because what I've read about it and actually talked to the investigators, it seems like a good study, but that's partly why we did the paper with aspartame, where we have data that I know is very good. We have, I think, about 20 times the number of cases of breast cancer that they have, and you look at the range of intake of aspartame that they have, it's far wider than they have. And we find nothing, and they find very strong relative risks. So, and of the other sweeteners too, that there is something strange, that there's some confounding or something that I don't understand, but we didn't miss relative risks of 2 in our study. I know that.
Well, it's strange for several associations. They reported a large number of associations which have not been replicated. Yeah. So probably part of it is data dredging, so they just publish positive results.
Well, I hope that Tosif with your IPD meta will be able to kind of hopefully replicate something, right? Oh, sorry.
Thank you. Thank you. If in your meta-analysis, your mega cohorts, if you can show that there is a benefit of the artificially sweetened beverage intake, is that because the artificially sweetened beverage per se is beneficial, or is it because the replacing calories are beneficial? So even if they've lost some weight, we know that eventually, based on the law of weight gain, that they will regain some of that weight. So the calories will be replaced. And what are they replaced with is the question. And nobody seems to want to answer that question properly. And the reason I raise it is because when we analysed, Alan and I and some other people analysed the last Australian National Dietary Survey, we showed that the people who completely avoided sugar-sweetened soft drinks actually were the people who got twice as many calories from alcoholic beverages than they did from sugar-sweetened, the highest consumers of sugar-sweetened beverages. So there is, at least in Australia, you're substituting one source of liquid calories with another. And it may be that alcohol shows improvements in HbA1c. There are studies that show that because it does downregulate gluconeogenesis. And it may be beneficial consumed in a healthy way. But it's also possible that alcohol is used in an unhealthy way and it promotes car accidents and domestic violence. So I think we have to be really, really specific about what's happening when you reduce sugar intake.
Yeah, in our studies, I have to go back to make sure it's 100% the case, but virtually always we would be controlling for alcohol intake. But the issue you point to, I think there's more going on than just calories. And when we look at, say, diabetes risk, that about half of the association with sugar-sweetened beverages is due to change in weight, presumably reflecting caloric balance. But there is, and I think we've talked about it before, just getting this huge bolus of sugar is which we get through a sugar-sweetened beverage serving or consumption in the long term. That has an adverse metabolic effect above and beyond the energy intake.
Yeah. Agreed. So would a better policy be that you reduce the sugar content in that beverage, which is what's happening? They reduce the sugar content to 5 and 6% instead of 10 and 12%. But actually that increases the glycemic index, by the way, and that's because lower concentrations of sugar are they're emptied from the stomach faster. So would a better policy be that instead of artificially sweetened beverages, that we're actively promoting things like isomaltulose as a sugar, that we promote breeding of sugarcane and other products like sugar beet so that they contain isomaltulose instead of sucrose, because it occurs naturally as a slower way of delivering glucose to the bloodstream.
I just wanted to add to that. We did the STEM trial, which we looked at caloric replacements with milk or soy milk for sugar-sweetened beverages, and we saw liver fat reductions. And Arnie Astrup had shown that with cow's milk. So you can have a caloric replacement. It's almost equicaloric for the milk, for the 2% milk. It's going to be less for the soy milk, because, as Laura showed, there's less sugar in it, even when it's sweetened. But we did see reductions in liver fat, meaningful reductions, more than 2%, absolute percent reductions. So I think you can think about things beyond low-calorie replacements that might have benefit for that big bolus of sugar.
Okay, can I answer Jenny's original question? She said our when we do substitution analysis, locally sweetened beverages, are they beneficial themselves or the replacement is better? So it's actually, the question is, if you're taking SSBs, when you switch to locally sweetened beverage, do you see a benefit? The question is not that locally sweetened beverage itself is beneficial. So these are different. That question is not being answered in the substitution analysis, because the issue is people who take sugar sweetened beverages, locally sweetened beverages, so one is reverse causality, then the residual confounding, which you can adjust for it, but even after adjustment remains, when there is behavioral clustering. So people who actually switch might have other behaviors which go along with it. For example, they might not be exercising still, they might still be a couch potato, they might still have bad dietary habits. So that risk itself is captured, and that's why a lot of that local sweetener beverage risk is behavioral clustering. They have those behaviors which is being captured. It's not the beverage is increasing the risk; it's actually the behavior which is increasing the risk. So that is not. So when you actually switch, when you do substitution analysis, the caloric difference appears, because usually majority of cohorts, the SSB risk ratio is around 1.2 to 1.3 for per serving increase, and for local sweetener is 1.3 to 1.03 to 1.15. So it's lower. So when you switch from a higher risk ratio to a lower one, you will see a benefit.
Simi, can I just jump in here to clarify some of the data? I already communicate with you already. In the Women's Health Initiative, we have actually published 3 papers on this, which unfortunately that you did not sign. We were very consistently showing SSB is directly related to increased risk of CVD and mortality. In fact, we have showed this with stroke risk in breaking down different kind of composition as well. But in terms of the sweeten, non-nutritional sweeten, as Ward mentioned, it is correct that majority of it at the depends on the baseline. In the WHI, the question that we were asked, just the question, you cannot really distinguish it, what specific type of sweetener. We asked them whether or not they consume diet Coke. That was the question that was asked in 2015. So we also, in that analysis, in fact, we also did a network meta-analysis nested in our original prospective cohort of the WHI. In that analysis, it clearly actually popped up, because the one good thing about network meta-analysis is you can actually rank the individual exposure of interest. In this case, the sweetener was actually the top risk factor in our network and meta-analysis. Now, the way we do this totally, the substitution, the displacement effect, it's also very complicated. In the Women's Health Initiative, the paper that the most recent one that we published in 2022, we specifically convert everything into percent energy, because the WHO's recommendation was 10% energy from sugar. And in the WHI, if you use the 2 level of, we actually also have 2-time measure of the food frequency questionnaire, a baseline and 3 years later, we took the average and quintile them. The top quintile is roughly about 15% energy from sugar, okay? So we picked that. It's also very clear. It's somewhere about like what you said, 1.25 to 1.3, that kind of risk associated with cardiovascular endpoint of interest. Now, that's in terms of replacement after control, putting energy in the model. Okay, so there's no escape if you look at SSB or any kind of added sugar, because they do contribute energy, right? So so sorry to keep talking about this, but I can end with this. I actually agree with the latest WHO, the 2020 three guidelines, which is very reasonable. They do emphasize on transitional use of these sweeteners, but emphasize whenever, particularly presenting cautions for children using both SSB and the non-nutritious sweetener. And of course, water is the best.
Any comment from the panel, and then we have to close the discussion. Please, Walter.
Just a note of caution, somewhat like Simon just mentioned, that all these recommendations talk about non-nutritive sweeteners. And as I mentioned early on, there are about 30 or so out there. And I think we just can't automatically lump them all together. They're just so different in action and structure. And we can probably talk about that in the afternoon, but I think there's so much heterogeneity there, they just can't possibly have the same biological effects.
Just to add, I think to Simon's, Simon and I had been offline discussing this also. The substitution analysis for energy does not make sense for locally sweetener beverage because it has no energy. So I think it has to be substituted on a volume basis. So that's the serving size substitution has to be made. I think that has to be, so any adjustment for energy would not work in those substitution analysis.
Can you do that with alcoholic beverages as well? Can you say if I substitute sugar-sweetened, 10% sugar-sweetened beverages with the same amount of beer, can you do that? Mm-hmm. Well, we should. It's a really important question.
Yeah, we haven't tried to put them in the same. We haven't put them in the same scale. No, we don't. They're controlled for separately. But those are clearly there's going to be big biological effects for sure in different directions.
Okay, thank you for a very engaging conversation, which we'll hopefully be able to continue on this afternoon when we meet back at 2:30. Enjoy your lunch.